Okay, we have question number 4. So this is a longer one. Question number 4. So given the list of derivatives for inverse trigonometric functions below, what most looks like the integral of inverse cotangent, or as it's given here, given the following choices? So basically what it's asking here is what is the integral of the inverse cotangent? Oops, inverse cotangent or arctangent. D of x, this is what we're looking for. What is that? And in the question, it gives you A, B, C, and D of the different answers of what this could be equal to. So we'll come back to that at the end after we solve the problem and see which one it matches. It also gives you here the derivatives of each one, and you'll see why later as we'll need it in our solution. Okay, so what we're going to do to work on this integration is we're going to use IVP, or integration by parts, or as I said, IVP sometimes it's called. And that tells you that if you have the integral of u by dv, you can rewrite it, I guess you could say, as u times v minus the integral of v times, or v by du. And this is useful when sometimes the integral that you're taking is difficult, and this version, the integral of v of the other half of it, with the other part, is a little bit easier to solve. So we can see how this is applied, because right now we don't know what this solution is. Let me just take a look. Okay. All right, so let's start by assigning different parts. So as you can see, we have a u and we have a v. So what parts of our equation are we going to set to u and v? So from our example, we are going to say, oops, sorry about that. We're going to let u equal to the inverse cotangent. Okay, and then essentially all we have left is for dv is du, because that, or sorry, not du, but dx. So this will become dv, and this portion will become u. As you can see here, there's a u and there's a dv. Okay, hopefully that makes sense. So I'm not blocking anything. So we need to take the derivative then of u in order to get our du term here. All right, so that means we need to take the derivative of cotangent, the inverse cotangent. So that's why this chart here becomes useful, because we need to take the derivative of that. So as you can see from using this chart, we can see that the derivative of the inverse cotangent, I wish I could circle it, but it's this fourth one here. So that is equal to minus 1 over 1 plus x squared. All right. And remember, we just need du. So if we rearrange slightly, move the dx up to the other side, we then have du is equal to minus 1 over 1 plus x squared. I don't know why I write it off center, but x squared by dx. Okay, so for the dv is equal to dx, sorry, if we integrate both sides, we just have that v is equal to x. So now we have everything that we need. We can start to sub things into our integration by parts. Okay, so remember our our u by dv is the question, right? We have what is the integral of the inverse cotangent of dx. Just going to move this over. Oops. So we make sure we have nothing. All right. And so that, using IBP, is equal to u. I'm going to use another color here. So we have u times v. So our u is this, this term. So that's inverse cotangent. I'm going to put each thing here into brackets so it's separated, times v, remember, which is x, minus the integral of v, which we just said is x, right, times du, which is this term here, okay? So putting that all in a bracket, 1 plus x squared by dx. All right. And remember, you're taking the derivative of, the integral of this entire term. Okay, so now we have our new IBP equation that we need to solve. So what we can do here, sorry, my mouse is on the wrong side. Okay, I'll just keep writing this purple. I'm just moving the x over to the other side so we don't have to write it with brackets anymore. Okay, so first what I'm going to do is move out this minus sign so it becomes plus this integral. And then we have actually moving the x over as well. So we have the integral of 1 over 1 plus x squared. Keep it inside the brackets so it's clear. Okay, so 1 over 1 plus x squared times x by dx. Okay, so now it's still a little bit too complicated to solve on our own, this integral here, but it's at least a little bit easier than what we saw originally, right? Because we had no idea what to do there. So now that we have this, what I'm going to do is let u equal to something new now. We're not using the same u as before. So I'm going to let u equal to 1 plus x squared, which is in the denominator here because it's a tricky term to deal with. So let's take the derivative of that. So du by dx is equal to 2x. And basically the reasoning for that is so that we can, since we'll be turning this term here into u, we also need to turn these x terms into u terms as well. So we're looking for x by dx on this side. We need something to equal that so that we can sub it in. And you can see that if you rearrange this equation by moving the dx to the right side and the 2 to the other side, so you have 1 over 2 by du, that's equal to x by dx. Okay, so hopefully that's clear. I don't want to block anything here. Oops. Scroll down anyways. Okay, so going back to what we had before. Dx. Okay, so this beginning first term remains the same because it's solved. There's no integral there anymore. And our second term, we can add the integral of 1 over u now, because remember, we let u equal to the denominator. And we have x by dx. Now that's turned into 1/2 du. As you can see, it's a lot easier to take the integral of this. So we have this first term that stays the same. And then we can take this 1/2 out because it won't affect the integral. It's just a constant. So 1/2 plus the integral of 1 over u by du. First term stays the same. And now we have an easy integral of 1 over u. And you should know, let me just write, maybe I'll write it in between here. So we know that the integral of 1 over u du is equal, well, I guess this isn't really necessary to write twice, but usually you would see it as 1 over x dx, so maybe you can write it this way. So we know that this is equal to the ln of the absolute value of x, okay, plus a constant c. So that should be either something you memorize or that's given to you, but it's a known factor. So that means evaluating this integral of u, we have that equal to ln of u, the absolute value of u, plus c. And so we have x, the inverse of cotangent x plus, well, distributing the 1/2, distributing the 1/2, we have 1/2 ln, and instead of u, remember what we did before, we let u equal to 1 plus x squared. So that's 1 plus x squared, absolute value, plus, well, multiplying the c by 1/2. When you distribute it into the bracket, that's still a constant, so you can leave it as c, okay? And this is what we got. So this is the final answer for the integral of the inverse cotangent, okay, dx. All right, double checking, and that looks good. And that's our final answer. So let's go back to the answers that they gave us, A, B, C, and D. And by comparing, you can see that our answer here is the same as their solution A. Okay? Looks good. So we can say, therefore, answer is A. All right, that's all for that question. Going through their solution, we've got the same thing. We can say correct solution, solution, and move on to the next question.